All right, so we've all got these super powerful AI assistants in our pockets and on our desktops now. But let's be real, how do we make them, actually trustworthy? How do we get them to be consistently accurate? That's the big question, and it's what we're going to dive into right now.
I mean, you've been there, right? You ask your AI a perfectly reasonable question, and it comes back with an answer that sounds super confident, totally plausible, but is just completely made up. It's one of the most maddening and honestly one of the most fascinating problems in AI today.
So to figure out how to solve this, we first have to really get our heads around the problem itself. Because it turns out, even the biggest, baddest AI models out there have a couple of pretty fundamental weaknesses.
The number one issue is what the experts call hallucination. It's a great word for it, really. It's when an AI doesn't know the answer, so instead of just saying, "I don't know," it invents one. It just fabricates information and presents it as stone-cold fact. And that risk, the risk of being confidently misled, is a huge barrier to us actually trusting these things.
So why does this happen? Well, one big reason is that a large language model, an LLM, is basically a snapshot in time. Its entire knowledge base is frozen, locked into the data it was trained on months or even years ago. So if you ask it about something that happened yesterday, it's got no clue. It's like it's working from a library where all the books are from 2021.
The other core problem is something called faithfulness. This is a really important idea. It's basically a measure of how well the AI's answer actually sticks to the facts it's given. When a model isn't faithful, it starts to drift, it improvises, it adds stuff, and that's when you get those unreliable and sometimes just plain weird answers.
Okay, so how do we fix this? How can we give our AI a connection to the present day and, force it to stick to the facts? Well, it turns out there's a brilliantly simple but really powerful technique called Retrieval Augmented Generation, or for short, RAG.
So here's the key difference. A standard AI model just digs around in its own massive but totally static internal memory. A RAG system does something way smarter. Before it even tries to answer, it goes out and does a search. It retrieves fresh, relevant info from an outside source like the internet or a company's internal document.
And that one simple change? Oh, it has huge benefits. Suddenly, the AI can give you real-time information. And because its answer is grounded in actual external facts, the chance of it hallucinating just plummets. And maybe best of all, it can actually cite its sources, so you can see where it got the information. That's explainability, and it's a game changer.
But this is where things get really, really cool. Because that basic RAG system is a great start, but it's not perfect. By being clever and engineering a more advanced system, we can push past its limits and build something that performs on a whole other level.
And this right here, this is the blueprint for that advanced system. Now, I know it might look a little complicated, but just think of it as a series of awesome upgrades we're going to install, one by one, to create a truly state-of-the-art answer engine. So, let's walk through it.
We're going to focus on 4 key upgrades, 4 specific improvements that take a normal RAG system and turn it into a high-performance machine for getting you the right answer.
Upgrade number 1 is all about that very first step, finding the information. We've got to get smarter about how we search, and this is where we bring in something called hybrid retrieval.
The magic here is that this approach gives you the best of both worlds. It uses old-school keyword search, which is perfect for finding specific names or product codes, and it combines it with modern semantic search, which is smart enough to understand the actual meaning and intent behind your question. When you put them together, you find way more relevant stuff.
Okay, for our second upgrade. Once we have all those search results, we don't just dump them on the AI's lap. Nope. We add a really important quality control step called re-ranking. Think of it like this. That first hybrid search casts a really wide net, right? But it might pull in some junk. Re-ranking is like a second, more expert filter. A specialized model sifts through everything and picks out the absolute best, most relevant documents to give to the main AI. All right, on to our third upgrade. And to get this one, you need to know about a really weird quirk with these big AI models. It's called the lost in the middle problem. Turns out, when you give an AI a long document to read, its attention is sharpest at the very beginning and at the very end. That means that a crucial fact buried right in the middle of the text can be completely missed. So what's the solution? It's this super clever trick called inverse packing. The system is smart. It finds the most important little snippets of info from all the documents it found. Then it takes the single most important bit and puts it right at the very beginning of the material it sends to the AI. And it takes the second most important bit and shoves it all the way to the very end.
It's basically gaming the AI's attention span to make sure it sees what matters most. Pretty smart, huh?
And our final upgrade, number 4, is all about efficiency. It's about focus. It's called context compression. So instead of feeding the AI these long, rambling documents that are full of fluff, this step intelligently pulls out only the most critical sentences and just throws away all the surrounding noise.
And how much of a difference does that make? Well, this one technique can cut down the total amount of text we pass to the AI by about 30%. Not only does that make the whole system faster and cheaper to run, but it helps the AI focus laser tight on what it actually needs to answer your question.
Okay, let's put it all together. We took a basic RAG system and we supercharged it with 4 big upgrades: a smarter hybrid search, an expert re-ranking filter, that clever inverse packing trick, and super efficient context compression. So, what do we get at the end of all that?
The results are pretty much exactly what we were hoping for. We get way higher accuracy in the answers, we get much better faithfulness, the AI sticks to the facts, and what that adds up to is a system that is just far more reliable and trustworthy. And because it's built out of these modular pieces, it gives us a fantastic blueprint for building even smarter AI in the future. You know, in the end, this whole thing is about more than just getting facts right. It's about building a better, more collaborative relationship with AI. And that leaves us with a really fascinating thought to chew on. As we build AIs that can find better, more truthful answers, what kind of deeper, more interesting questions are we going to be inspired to ask?